Hello and welcome to the vodcast about balancing ionic formulae. I have 3 rules for the balancing of ionic compound formulae. Number 1, if the numbers on the charges are the same, then we do nothing. If the numbers on the charges are different, then we swap and drop. And number 3 is if the cation is +4 and the anion is -2, then it becomes a ratio of 1 to 2, or cation anion 2. So let's now consider what an ionic compound is. Generally, it's a metal and a non-metal. The metal is a cation, which has a positive charge, and the non-metal is an anion, which has a negative charge. And then there's the electrostatic attraction between the two. In my way of thinking, as long as you've got a cation first and an anion second, then we're ready to go. So let's think about rule number 1. If the numbers are the same, just put them together. Let's look at the first example. Sodium is +1 and chloride is -1. The cation is +1 and the anion is -1. So they cancel each other out. And so it becomes NaCl, or sodium chloride. Now let's look at another example. We've got calcium 2+ and sulfate 2-. The cation is +2 and the anion is -2. So again, they cancel each other out. And it becomes CaSO4, otherwise known as calcium sulfate. Now let's try some examples. Remember, as long as you've got a cation first and an anion second, we're just going to worry about the numbers on the charges. So here are some examples. Aluminium is +3, phosphate is -3. Magnesium is +2, sulfide is -2. Sodium is +1, hydroxide is -1. Manganese is +3, nitride is -3. Ammonium is +1, nitrate is -1. Now you have a go, get the formula, and then name it. I'll give you a second to do it. Okay, so for the first one, it's just AlPO4. Because 3+ and 3- cancel each other out, we just put them together. And this compound is called aluminium phosphate. In the next one, magnesium is +2 and sulfide is -2. They cancel each other out, so it becomes MgS, which is called magnesium sulfide. Then number 3, sodium is +1, hydroxide is -1. So the charges cancel each other out and becomes NaOH. And that's called sodium hydroxide. Then we've got manganese +3 and nitride -3. They cancel each other out and it becomes MnN, otherwise known as manganese nitride. And then last of all, we've got ammonium +1 and nitrate is -1. So the charges cancel each other out. We just put them together to make NH4NO3. And this is called ammonium nitrate. Okay, so now let's consider rule number 2. If the numbers are different, then swap and drop. Remember, we need to have a cation first and an anion second. So let's look at sodium that is +1 and sulfide that is -2. The numbers are obviously not the same. So we swap and drop the 1 from the sodium and it goes down the bottom of the sulfide. And we swap and drop the 2 from the sulfide, and that goes down the bottom of the sodium. So it becomes Na2S. We don't need to show the number 1, just having the sulfide there is enough. And so it's called sodium sulfide. Let's have a go at another one. Remember, as long as you've got a cation first and an anion second, we don't need to worry about the charges, we just worry about the numbers. So we have ammonium that is +1 and carbonate that is -2. Again, the numbers are obviously different. We swap and drop the 1 from the ammonium and we swap and drop the 2 from the carbonate. So it becomes NH4,2CO3. The NH4 needs to be in brackets because it's polyatomic, which means the entirety of NH4 has the charge of +1. Not the N, not the 4. NH4 is +1. So it needs to be put in brackets. So let's do some examples. Remember, you've got to have a cation first and an anion second. And as long as you have that, then we just have to worry about the numbers. So the examples we have here are lithium is +1 and oxygen is -2. Calcium is +2, nitride is -3, aluminium is +3, chloride is -1, ammonium is +1, phosphate is -3, and then we have lead that is +4, and fluoride, which is -1. You have a go at working out the formula and the name. I'll give you a minute to do it. Okay, so lithium +1 and oxygen is 2-, so it becomes Li2O, and it's called lithium oxide. Next, we've got calcium that is +2 and nitride that is 3-, so it becomes Ca3N2, and that's called calcium nitride. Then we have aluminium that is 3+ and chloride that is -1. It becomes AlCl3, and this is called aluminium chloride. Then we have NH4 +1 and PO4 3-, and that becomes NH4 3PO4, and this is called ammonium phosphate. And last of all, we've got lead that is 4+ and fluoride that is -1, and it becomes PbF4, which is called lead 4 fluoride. Whenever there's more than one charge for a particular element, we use Roman numerals to identify it. In this case, lead comes as 2+ or 4+, and so here we've written lead 4 fluoride. Okay, then rule number 3. If the cation is +4 and the anion is -2, then it becomes Ca2. Let's look at an example. We've got lead 4 carbonate, Pb 4+ and CO3 2-. So if we follow the rule, it becomes Pb, and in brackets we've got CO3 in bracket 2. This is because we're just trying to balance the charges. The cation is +4, so we need 2 anions of -2 to give us -4 to balance out the charges so they can cancel out. Okay, let's try some examples for rule number 3. And rule number 3 is if the cation is +4 and the anion is -2, then it just becomes cation anion 2. So the 3 examples I have for you are lead 4 sulfide, tin 4 sulfate, and nickel 4 oxide. I'll give you a second to do them. Okay, lead 4 sulfide, it's Pb4+ and S2-, and it becomes PbS2. Then we've got tin 4 sulfate, Sn4+ and SO4 2-, and it becomes Sn bracket SO4 bracket 2. And last of all, we've got nickel 4 oxide, which is Ni4+ and O2-, and that becomes NiO2. Thank you for listening. Thank you for paying attention, and I hope you've enjoyed it and maybe even learnt something. Like and subscribe if you like, and I'll catch you later. Bye now.